One snap cable, and elevators still don't fall. A safety trick from 1852 makes sure of it. You probably pictured it. The cable snaps, the car free falls, game over. It's a classic movie moment, and it's also almost never how elevator failures actually go. The truth is stranger and honestly more reassuring. Elevators are one of the safest machines humans use every day, and the reason has nothing to do with luck. Start with an assumption everyone gets wrong. Elevators don't hang from one cable. A typical passenger elevator hangs from 4 to 8 steel ropes, run in parallel, and each one alone is rated to hold the entire loaded car by itself, with a safety margin on top of that. Losing one rope doesn't even register with the passengers. The others simply take the load, and an inspector replaces it later. To get a true free fall, you need every single rope to fail at the exact same instant, something that essentially never happens in a maintained building. Cables are inspected on a strict schedule and swapped out long before they're anywhere near their limit. Fine, let's break the thought experiment and imagine every rope somehow lets go at once. Even then, the car does not simply plummet. That's because of a second, completely separate system, one that doesn't care about the ropes at all. It was invented in 1852 by an engineer named Elisha Otis, and it's the reason he could safely demonstrate cutting his own elevator's rope in front of a crowd and live to tell about it. The trick sits in a small spinning wheel called a governor, mounted at the top of the shaft and connected by its own separate rope that moves with the car. As long as the car travels at normal speed, the governor just spins along quietly. But if the car starts accelerating, the unmistakable signature of a real free fall, the governor spin speeds up past a set limit, and it trips. Tripping the governor yanks a lever inside the car, and that lever forces a pair of steel wedges outward against the vertical guide rails that run the length of the shaft. The faster the car tries to fall, the harder those wedges bite. It's a self-reinforcing clamp, jaws of case-hardened steel gripping onto tracks that aren't going anywhere. Within a few feet, the car doesn't drift to a stop. It grips and it holds hard. And that's still not the last layer. Below the shaft sits a hydraulic or spring buffer, essentially a giant shock absorber, in case a car somehow reaches the bottom anyway. Motors carry mechanical brakes that clamp shut the instant power is lost, which is also why an elevator doesn't drop when the building loses electricity. It simply parks. Doors won't even open unless the car is correctly aligned with the floor, so you can't step into an empty shaft. Elevator engineering stacks independent backups on independent backups, precisely so that no single broken part, or even several at once, can end in a fall. The numbers back this up. In the United States, elevators make something like 18 billion passenger trips a year, and fatalities from a genuine mechanical freefall are a vanishingly small fraction of that. Most incidents involve doors or maintenance work, not falling cars. You are by a wide margin safer in an elevator than on the stairs right next to it, and safer still than in the car you drove to the building. The design has had over 170 years and a small mountain of building codes to get this right. So the next time the cable snap scene plays in a movie, remember what's actually holding that car up. Not one rope, but several. And behind them, a spinning governor and a pair of steel jaws invented before the Civil War, still doing their job today. It isn't magic and it isn't luck. It's more than a century of stacked redundancy. If that changes how you see the ride to your floor, that's exactly the point of this channel. Subscribe to Cutaway. We keep cutting things open.